We are going to have a quiz next Wednesday. So whatever covers from the last quiz until today will be the subject of next quiz. It will be about 2 hours and maybe around 200 points. So you can prepare two-page cheating sheet. What's the next page? My handwriting is still awful. So I stopped in the middle of probably the last integral. That is I minus 1 to 1 square root 1 minus x squared dx. Probably I should take off my mask too. Sometimes it's kind of difficult to breathe. So instead of doing this integral, we are considering this so it does have actually 4 minus plus I minus I and singularity at minus 1, 1, right? But the singularity at 1 and minus 1 is a bit difficult to handle, so we are going to try to avoid it as much as possible. So instead, we are putting the branch cut and put the contour like this. So actually, plus minus 1 is not a singularity because the limit z plus 1, z minus 1, root z square minus 1. Equals to 0, right? So it's not a singularity. So z plus minus 1 is not a 4. It's finite, right? So, because you may think that because z plus minus 1 is in the denominator, it may look like it's in 4, right? But if you take a limit by multiplying z minus 1, then it actually, the z minus 1 goes to the square root of the z minus 1 to the numerator, right? Numerator. So actually going to 0. So it's not a singular point, it's not 4. So when you do this control integration, you only need to worry about these 2 points, I and minus I. So C1, C2, C3, C4, this is CR, right? So C is consists of this. So I may just need to make a copy of this. Copy. And next page. Okay. Here too. So let's put divide by this region 1, 2, 3, 4, 5, and 6, right? And then we are expressing the point at any point by this way, R1, theta 1, R2, theta 2. So Z can be expressed as Z is plus 1 plus R1 exponential y theta 1, or Z minus 1 plus 1 plus R2 exponential y theta 2. So Z plus 1 R1 exponential y theta 1, Z minus 1 is R2 exponential y theta 2. So Z squared minus 1 to the 1/2 is actually R1 exponential y theta 1, R2 exponential y theta 2, 1/2 is square root of R1 R2 exponential I 1/2 theta 1 plus theta 2, and square root of R1 R2 can be written as Z squared minus 1 to the 1/2 absolute value, right? So this is important. I2 theta 1 plus theta 2. This expression is important for later purpose. So we can actually represent this as a one, 2, 3, 4, 5, 6. So this point is 1, this point is 2, 3, 4, 5, 6. So 1, 2, 3 is actually 1, 2, 3, just above x. 4, the angle for theta 1. Zero, right? How about the angle theta 2? Zero, right? Theta 1 and 0, theta 2 is 0. How about position 2? This 2 point is actually left side of 1, right? So theta 2 should be pi. Theta 1 is still 0. So theta 1 is 0, theta 2 is pi. How about this point 3? It's both from left side from either -1 or +1, right? So theta 1 and theta 2 are both pi. How about point 4? Same, right? The angle from this -1 is still pi, and the angle from z equal to 1 is pi. So theta 1, theta 2 is pi. How about point 5? This point, the angle from -1 is you have to circle around. So theta 1 should be 2 pi. Theta 2, still, this point is still on the left side of this point 1. So its angle should be pi. Theta 1, you have to circle around, so it's 2 pi. Theta 2 is 2 pi, right? It's not 9. Is it? I may need to still oh. Copy, delete. Probably I need this. What happened? I think I made a mistake. Inserting one extra page so that I don't need. Copy, paste. Okay. There may be some time limit for this copy and paste. Copy, delete. I also need this. Copy, delete. Finally, this. Copy, delete. I need strong caffeine too. How many pictures I have? Oh. Oh. What's happening? Paste. Okay. Paste here. Paste. Okay. So we need to have a half angle. Finally, it's half angle. Theta 1 plus theta 2 by 2. This is 0. Pi over 2. Pi. Pi. 3 pi over 2. 2 pi, right? So we are going to consider this function. So I'm going to say z squared minus 1 to the absolute value of right? So this is absolute value of square root r1, r2, exponential I 0 pi, right? How about 2? R1, R2, exponential I pi over 2, square root of R1, R2, exponential I pi, square root of R1, R2, exponential I pi, square root of R1, R2, exponential I 3 pi over 2, square root of R1, R2, absolute value, exponential I 2 pi. So at 3 and 4, they are the same value, right? How about 1 and 6? 0 and 2 pi, same value, right? So 1 and 6, single values. And 3 and 4, again is single valued, right? How about 2, which is square root of r1, r2, exponential I pi over 2, and 5, square root of r1, r2, exponential I 3 pi over 2, right? So this is I, this is minus I. I will just copy. So you may think complex integration is very, very complicated and difficult, but this is not so. You just need to write a proper diagram and put some table. That's all you need to do. So once you get here, then you're almost ready to go for next table, just for your convenience. Copy, delete. Paste. So I need this angle and step. So C1 GZ GZ C4 GZ DZ is what? It's actually minus infinity to minus 1, square root of x square minus 1, x square plus 1 dx, right? Plus C4 is minus 1 to infinite, root x square minus 1, x square plus 1 dx. Because for 3 and 4, this function 1/2 is actually just okay, minus 1 minus 1. You have x square minus 1 exponential I pi, right? Maybe I need to make a copy paste here, right? 3 and 4 is minus 1, minus infinite minus 1, and minus 1 to infinite. And this function is I pi, so it's minus 1, right? So what happens to the C1 plus C2? It becomes the same integral but with the opposite lower and upper bound. So if you change the bound, you have minus sign, right? So it's actually, if you add the C1 and C4, you will get 0. How about C2 and C5? Oh, sorry. We have to put this. So maybe I have to change the order. So this is C2 is minus 1 to 1. Square root 1 minus x square. X square plus 1 exponential I pi over 2 dx plus 1 to minus 1 square root of 1 minus x square plus 1 exponential 3 pi over 2 over dx is actually 2 over I minus 1 to 1 dx root 1 minus x square plus 1, right? And we know that this row, C row, I think you can do that as homework now. Then the only thing you need to do is estimate the residue, right? So I'm going to make a copy of this again once more. Copy. Paste. So C is if we integrate over C, GZ, is actually we have I over 2 minus 1 to 1 root 1 minus x square plus 1 dx, which is actually I equal 2 pi I residue g exponential I pi over 2 plus residue g exponential I 3 pi over 2. So GZ so if you take the residue, I this is actually square root of 2 I, right? And this is 2I over 1. No. G minus I. Square root of 2I, 2I. Minus how about the other residue? Residue G exponential I 3 pi over 2 G 2 minus I C plus 1, and this is actually square root of 2 minus I C plus I C plus I C minus I is square root of 2 minus I minus 2I. So 2 pi I times residue G exponential I pi over 2 residue G exponential I 3 over pi 2 is actually 2 pi I times I 2I plus square root of 2I 2I, right? Because minus become here, you have minus and minus become plus. So it becomes I cancels each other here. Two cancels here. So it becomes square root of 2I over 2 pi, right? Therefore, Therefore, so this is 1, 2, no. 2, 3, 2 by 2. 2 by times I becomes 2 pi over square root of 2I. So cancels each other. I pi over square root of 2. Again, you have pi, right? It's very interesting that the left side of the integral doesn't seem to have anything to do with the circle, right? But still we have pi. So it seems like if there is some supernatural thing, or sometimes we call God, actually something or some supernatural thing created this universe, he probably have left a sign. Pi everywhere. So this may have something to do with our flat space-time. Called Minkowski time. Space-time. The circumference and radius is the ratio between circumference versus diameter is equal to pi, greater than pi, less than pi. It depending on the coverage of the space-time. And we are living in the space-time that this ratio is exactly pi. I don't know, I'm not very philosophical or religious, but because our space-time curvature dictates that the ratio between the circumference and the diameter of the circle is pi, or the total angle inside of the triangle is pi, right? 삼각형의 내각의 얼마? Pi. So, exactly pi. So if we are living in different space-time which can be greater than pi or less than pi, then I don't know. But somehow, many integrals, the result is pi. So it seems like it's a signature of our space-time. Some supernatural thing wanted to leave a signature that he created this universe. May have something to do with this pi. Maybe true or not. This is just my speculation. So before I proceed, maybe we can take a break for 5 minutes. What do you think? So I'm going to cover a little bit more after this class, but this is up to the next quiz. this is up to the topic for next quiz. So you don't have to worry about too much about the topic that I'm going to cover after the break. So I'm going to cover partial differential equations. Topic 2. So partial differential equation is actually the equation that involves partial derivative. Containing partial derivative. So typical partial differential equation is something like this. This is one-dimensional heat equation. Diffusion equation. Or sometimes we have round T round U xt plus U round x round U plus 1 over rho round x round pxt nu round x round uxt is equal to 0. This is also a very interesting equation. It's one-dimensional. Navier-Stokes equation. For fluid dynamics. So mechanical engineering major will have to solve this Navier-Stokes equation. And three-dimensional form is something like this. U P divergence of U is equal to 0. That's a three-dimensional form. But before we deal with the partial derivative and partial differential equations, it may be, useful to review the sum of the ordinary differential equations before we proceed. So I'm going to do some review. Ordinary Simple one-dimensional differential equation. Probably you have forgotten already, but there is a method called integrating factor. Hx such that so this problem can be by finding integrating factor. So typical one-dimensional ordinary differential equation can be solved by finding integrating factor. Then this can be you just need to integrate the whole thing, right? So hx, yx is you have to integrate hx prime, qx prime, dx prime with some constant. Then yx is 1 over hx, hx prime, qx prime, dx prime plus c. So the question is, what is hx? So can I move on? So dx, d, hx, yx is actually hx, dx, dyx plus dx, dhx, yx, right? It's supposed to be hx, qx by the definition of integrating factor. Factor. So if hx is non-equal to 0, you can divide the whole thing. So then dx dyx plus 1 over hx dx dhx yx is qx, right? How about, but the original equation, on the other hand, the original equation is dx dyx px yx is qx, right? So this and this should be the same. Px should be 1 over hx dx dhx, right? And 1 over hx times dx dx is logarithmic derivative. dx d log hx, right? Or log hx is simply px prime dx prime. OHX is exponential px prime dx prime, right? So y-axis is actually, so I'm going to move a bit slowly here. Therefore, yx is 1 over hx qx double prime hx double prime dx prime c exponential px prime dx prime qx double prime exponential x prime h p s ds dx prime exponential minus px prime dx prime here dx prime x prime ps ds q x prime dx prime plus c. So maybe we can take some example. Dx dy plus y over x is x. So px is 1 over x, right? Qx is x. What is the integrating factor? Hx exponential x prime dx prime, right? Exponential log x, which is x, right? So yx is actually 1 over x hx is x prime qx is x double prime dx prime plus c, right? Which is x 1 over x squared when you integrate 1 over 3 x squared, right? Plus c is 1 over x. So we have x squared over 3 plus x over c. That's your solution. So first order one-dimensional ordinary differential equation is always solvable. The general second order equation, that's the only thing you need to do for this semester. So maybe I'll just stop. No, just wait here until you finish. This is the inhomogeneous second order differential equation. Inhomogeneous second order ordinary differential equation. Right? Step number 1. Solution of homogeneous differential equation. That is px. I'm just put this way. Qx y prime r x y is equal to 0. At this stage, we don't actually know the exact form. Just let us say that yh1, yh2. And then define particular solution. So u1x, yh1, u2x, yh2x, such that dx du1 yh1 dx du2 yh2 is equal to 0. So we actually have a constraint on u1 and u2. This is constraint on u1 and u2. That means if you differentiate u1 and u2, and if you sum over them is equal to z, means you like to try u1 and u2 like constant, right? So that means we would like to try u1 and u2 as a constant, like a constant. Then we substitute back to this equation into the original equation. I'll let you copy. So some of you who have taken my class may remember that, right? It's only about 6 months ago. So you should have still have good memory, at least for 6 months. But frankly speaking, probably you have forgotten it already, right? Well, I think it's only need to remember that you once learned this. As long as you remember that, then that's all you need. You don't have to remember the details. You cannot. I do, but it's actually my worst thing is I have like a photographic memory. I remember most of the things. I don't forget. That's sometimes troubling me. Sometimes you need to forget. So substitute, we have this equation. This is equation 1. Back to the original equation. Yp back into the original equation. So we have px yp double prime q yp prime r yp is equal to s, right? So yp double prime is u1 yh1 plus u2 yh2. Let's start with the single derivative. Derivative is u1 yh1 prime u2 yh2 prime plus u1 prime yh1 plus u2 prime yh2, right? But we have assumed that this is equal to 0. If you make a double prime, that is u1 prime, uh1 prime, u1, uh1 double prime, u2 prime, yh2 prime, u2, yh2 double prime. So we just substitute back into this original equation. So p yp double prime q yp prime r yp is you have a p u1 prime yh1 prime u1 yh1 double prime u2 prime yh prime u2 yh2 prime plus q u1 yh1 prime u2 yh2 prime plus r u1 yh1 u2 yh2, which is okay, you can set u1 pu yh1 double prime q yh1 prime plus yh1 u2 p yh2 double prime q yh2 prime r yh2, this is 1, plus p u1 prime yh1 prime u2 prime yh2 prime. What happens to this term? yh1 was a homogeneous solution. It should be 0, right? How about this 2? Goes to 0. So only thing you need to remain is this is equal to s. So we have two conditions for two equations. We have this equation and previous. So we have second constraint too. So we have these two things. Let's copy. So we have a condition for u1 prime and u2 prime. Okay, I will just, so we have y h1 u1 prime, y h2 u2 prime is equal to 0, and y h1 prime u1 prime y h2 prime u2 prime is equal to sx divided by px. Of course, px is not equal to 0. So we have two equations, two unknowns, right? So let's say A is equal to yh1, yh2, yh1 prime, yh2 prime. And let's say u prime as u1 prime, u2 prime. Then we have this matrix. A times u prime is this 0 to px over sx. Let's say this is big S. So this is 2 by 2 linear equation. So can you solve this equation? What is the condition for the existence of u prime? Determinant A is not 0, right? You remember that? Again, last semester, towards maybe April, March, April, you learned the inverse matrix, right? The condition for the inverse matrix is determinant A is non-zero, right? For exist, determinant A is non-zero, right? So if A is A11, A12, A21, A22. Anybody remember the formula for determinant for this matrix? A inverse is determinant A, A22, A11 minus A12 minus A21. Probably this form, you may remember that now, or you can check the note. So using this, right? A YH1, YH2, YH1 prime, YH2 prime, I think. So inverse matrix is 1 over determinant A, YH2 prime, YH1 minus YH2 minus YH1 prime. And determinant A is YH1, YH2 prime minus YH2, YH1 prime. And sometimes it's called Wronskian. It is a name. Then this matrix U1 prime, U2 prime is 1 over Wronskian times YH2 prime minus YH2 minus YH1 prime, YH1 times 0 Sx divided by Px is actually Wronskian over minus Px Sx YH2x and this Px Sx yh1x. Therefore, u1 prime is Wronskian x px minus sx yh2x. u1, u2 prime is Wronskian x px sx yh1x. So let's make a copy of this. Copy. Paste. Therefore, u1x is actually minus Wronskian x prime px prime sx prime yh2x prime dx prime. u2x is Wronskian x prime px prime sx prime yh1x prime dx prime. So the solution, general solution yx is c1 yh1x c2 yh2x minus yh1x times this. Dx prime plus yh2x Wronskian x px prime sx prime xh1x prime dx prime. That's your general solution. So that means linear second order differential equation always has a solution. Yeah, that's